Here we have a problem on derivative. Okay, let's go to the question. If x to the yth power equals to e to the power of x negative y, prove that dy over dx equals to ln x over 1 positive ln x whole square. Okay, in the given equation, I have to find the derivative of y with respect to x, and the result has to be ln x over 1 positive ln x whole square. Okay, this ln x represents the natural logarithm. Okay, now let me take the given equation as it is. That is x to the power of y equals to e to the power of x negative y. Okay, now let me consider stuff on the left side. So here we have variable y at the exponent. When we have variable at the exponent and I want to find derivative, the base must be the mathematical constant e, like the one we have on the right side. But here the base is not the mathematical constant e, so this is a variable x. Okay, it is a bit difficult to get derivative for this one. What do we have to do for that? We have to do logarithmic derivative. That is, before we find derivative, we have to take logarithm on both sides. When we take logarithm on both sides of this equation, I can use the properties of logarithm. In particular, I can use the power rule of logarithm to get rid of the variable y at the exponent. Once I get rid of the variable y at the exponent, I can find derivative easily. Okay, now what I have to do is I have to take natural logarithm on both sides. Why should I take natural logarithm on both sides? Because the derivative will work only with natural logarithm. Okay, now let me take natural logarithm on both sides of this equation. Then I'm getting ln of x to the power of y equals to ln of e to the power of x negative y. Okay, here on the left side, I'm going to use the power rule of logarithm. Because the argument of a logarithm is a power. So when I use the power rule of logarithm, the exponent we have over here can be moved in front of the logarithm. Then I'm getting y times ln x equals to the same thing. Here the argument of the logarithm is a power, so the exponent we have over here can be moved in front of the logarithm according to the power rule of logarithm. Then I'm getting x negative y times ln e. Okay, here y times ln x equals to x negative y, and here it's a natural logarithm. Whenever we write the spelling ln, everyone can understand it's a natural logarithm and its base is always e. Okay, here in this logarithm, the base is e because it's a natural logarithm. Already we have the argument, that is also e. In any logarithm, if the argument and base are equal, then the value of such logarithm is 1. So the value of this logarithm is 1. So we can write 1 as a value for this logarithm. Then I'm getting y times ln x equals to x negative times 1 is just x negative y. I think we can solve for y in this equation because here on the left side a term contains y, on the right side a term contains y. We can solve for y. Once we solve for y, easily we can find the derivative, that is dy over dx. Okay, now to solve for y, we have to contain, we have to collect the terms which contain y on one side of the equation. Okay, let me add y to both sides to get of the term which contains y on the right side. So this negative y, positive y will cancel. Then I'm getting y times ln x positive y on the left side. On the right side we just have x. Okay, here in this expression we can factor y because the first term contains y, the second term contains y. Okay, when I factor y out, then I'm getting ln x positive 1 equals to x. Now to solve for y, I divide both sides by ln x positive 1. Let me do it. Okay, here this ln x positive 1, ln x positive 1 will cancel, then y equals to x over this ln x positive 1 can also be written as 1 positive ln x. Okay, now I have solved for y. Now what I can do is I can start finding derivative. Okay, here when I find derivative of this y with respect to x, I'm getting dy over dx. On the right side, we have variable x in both numerator and denominator. Whenever I want to find derivative of a stuff which contains variable in both numerator and denominator, I have to use a coefficient rule of logarithm. What is coefficient rule of logarithm? Let me consider two variables u and v which are in division, and I want to find derivative of this u over v. So for that, what I have to do is I have to square the denominator, that is v square. The same v should be taken over here. Now I have to get the derivative of the numerator u, then it will become u prime. Now I have to take negative sign. Now what I have to do is I have to keep the numerator u as it is and get the derivative of v. So this is a coefficient rule of a logarithm. Now we can follow the same coefficient rule for this stuff because it contains variable in both numerator and denominator. My first step is I have to square the denominator like what I have done over here. So here the denominator is 1 positive ln x, 1 positive ln x, the whole square. Now I have to keep the same denominator over here as it is. I have to get the derivative of the numerator. So the numerator is x. When I get the derivative of this numerator x with respect to x is just 1. negative. Now I have to keep the u as it is. U means the numerator as it is. I have to get the derivative of the denominator. Okay, when I find derivative of this denominator, the derivative of this constant 1 will become 0, and the derivative of this natural logarithm of x will become 1 over x. So this x will cancel out. Then I'm getting dy over dx equals to 1 positive ln x times 1 is just 1 positive ln x, and here we have negative, and we just have 1 divided by 1 positive ln x the whole square. So here this 1 and negative 1 will cancel out. Then I'm getting ln x over 1 positive ln x the whole square. Okay, now I got dy over dx. So dy over dx equals to ln x over 1 positive ln x whole square. So this is what I have to prove according to the question.